I'm Bill Caper, and this is the Leverage Loop Learning Discussions podcast. Today's episode, we're going to be focused on what I'm calling the engineering paradox, really the tension between building for features and building for the now and market fit versus building for scale, longevity, or the long term. I've asserted previously that my top three tenets for building software are keep it simple, stupid, followed by YAGNI, which is you aren't going to need it, so don't build it. And then don't repeat yourself or dry. And if I had to sacrifice, I would sacrifice working from the bottom up in that order. But the engineering paradox actually is a very interesting challenge or dilemma, because when you're focused on building for market fit, you can potentially build at the exclusion of scale and put yourself into a situation where you find market fit, and the pressure for keeping that competitive advantage of that market, of that early market fit, means you then have to build more features and you can't actually ever get to scale. The alternative is you build for scale before you have market fit, and you violate, in essence, YAGNI, which is building before you need it. So how do you find the right balance? Is that paradox real, or is the paradox a trap you can fall into that you have to avoid? So with me today, I'm really happy to be here with Tim LeMaster. Tim is a principal engineer at Pangea Money Transfer. He's been there for about a year and a half now. I've worked with Tim at a few different companies, both a early stage startup, Huckleberry Insurance, where we did some re-architecture and really helped put that company on a really strong growth curve. And then even prior to that at Root Insurance, which was a later stage startup that actually went through IPO while we were both there. So Tim, thank you for taking time to do this, and thank you for being here on the Leverage Loop podcast.
Oh, thanks for inviting me, Bill. I'm really happy to be here.
And Tim, do me a favor. We haven't really talked much about this, but as a principal engineer at Pangea, what do you focus on primarily in your role? And where is Pangea at in terms of its own journey as it matures as a startup? Where are they at on both the business curve of that? Are they still early stage or later stage? And on the engineering scale, where are they at in terms of, that the sort of rigor you see at a later stage company that's really found scale and found fit versus the earlier stage where things are a little messy and still a little fluid?
Sure, absolutely. At Pangea, I focus on a couple of things. As principal engineer, one of my primary responsibilities is to unblock the engineering teams, right? We have three squads that kind of focus on different parts of the business. Each of those has a lead engineer, and I help those lead engineers design their features, vet their technical designs, help them with the more complex parts of it, and just assure we're building the right thing for the business. I also dig into our scaling issues in AWS and make sure that we're keeping up with our load, especially big time of year coming up for us is Mother's Day. And so we kind of investigate even more due diligence on what's happening there, because we see up to like 3 times the number of customers on Mexico Mother's Day, which I think is next Tuesday.
Wow.
And then I focus on our infrastructure as code to help us build that out quicker and be able to reproduce changes from our dev environment to our production environment quicker than we have in the past. As far as where is Pangea on the scale of things, Pangea has been around for a little while, but I would say they're more of in that still kind of a early stage startup like frame of mind. They've grown slowly over the course of years. Recently, we're acquired by a much, much larger company called Innova. And Innova is really looking for them to, 10x their growth over the next few years. So it makes sense to be part of the Innova, portfolio of companies. So in that mind, we're really still seeking product market fit. I don't think our, customer acquisition cost nor our kind of long-term retention is where it needs to be. So we still need to work on product market fit, but we do have, a reasonable amount of scale.
That's pretty interesting. Well, I think any startup would say they're always seeking better customer acquisition costs and better market fit. So I don't think they're alone, or you guys are alone there. Well, I am curious, as I've never used the product. Is it a native first, mobile first experience? Is it a more of a hybrid, both rendered and desktop? Tell me a little more about the architecture.
Yeah, absolutely. It is mobile first. Most of our transfers come through the mobile apps. We have iOS and Android apps. We do have a web site, and most users experience their first transfer that way, and then quickly download the apps. More convenient on your phone if they stick around. So the apps are native, Swift and Objective C, Java and Kotlin on the Android front, and then we have a backend written primarily in .NET. So we expose an API for the web and the mobile apps to call. And yeah, we submit transactions to our API. We do a lot of background work because we need to reach out to charge cards, and we have partners who we actually use to send money to other countries. That all happens in the background with an asynchronous worker.
Very cool. And I know, from our previous experience working together, the thing that I really respect about you as an engineer and an engineering leader is your pragmatism, the ability to take problems and really balance, the need for business value, the need for impact, we'll call it, with the customer, but also sustainability, durability in the solutions you're building. And so like my first question, which really ties back to the topic that we're talking about, the engineering paradox, is when you think about that paradox, how do you approach it? How do you approach finding market fit for either greenfield work you're doing, or maybe even re-architecting in a brownfield, versus that durability? And is it a paradox, or is it a paradox that you could simply fall into or create on your own?
Yeah, I definitely think it's a paradox of your own making if you're not careful. In the greenfield approach, in the early stage startup, like we said earlier, you're seeking, product market fit. That by definition requires trying and testing a lot of things, right? You do a lot of A/B testing. You may put out a painted door. You may quickly change up how a feature works. If you're successful at that, that's kind of a good indication that your architecture is flexible, right? You're able to quickly adapt to the needs of the business and ship features out quickly. You probably have a strong underlying architecture that's well encapsulated. Things you're not repeating yourself. Things are in one place. There's probably good tests. It's possible you're not there, right? Engineers could just be hacking things up, making them work, that kind of things, but that's typically revealed by your failure rate, right? You'll push something out, you have to roll it back frequently, or things are just riddled with bugs. You have strange interactions between new features because there weren't enough tests or there wasn't enough testing. And the good news is, I think, is this flexible architecture that allows you to experiment in the early days will allow you to scale in the later days, right? Your components will be well encapsulated, your database access, your file access, your APIs. You'll be able to pull those apart, scale that database up as you need to, change the database technology without too much disruption, replace an API that's not working well for you if it's well encapsulated. So I don't think it's a paradox, but I think if you're not careful, it can seem like a paradox.
And how about in the brownfield example where, there's pressure to, you have a solution, there's some things that are potentially limiting in that solution. Someone's made the decision to actually go and make an investment in trying to re-architect or clean up the existing code, yet there's pressure to deliver and get value out the door. And I'm using re-architecture. It could simply be a refactor. It doesn't have to be redoing the entire stack. But in that scenario, right, that sort of that tension, if you will, between the let's solve a problem internally, but that's also still get external value. Is there a paradox there of doing one or the other and trading off, or is it just is it, again, in your opinion, is it just a balance?
Yep. Yeah, no, that's a good question, Bill. So I think it can be a kind of give and take and balance, and you can kind of break trust there if you're not careful, right? I think engineers sometimes want to make changes for, the sake of chasing the perfect. And if you're chasing a re-architecture or a redesign or whatever, if you can't express it in terms of, what's the business going to get out of this, right? Is it going to improve velocity later? Is it going to reduce defects? Is it going to make it safer to ship, right? What's the business value behind this? As I love developing software, I love engineering software, but in the end, it's to serve our customers. And if we're making changes because we think it's cool, we want to learn a new database technology, or we want to introduce some pattern because we saw it on some podcast the other day, but we can't identify the business value behind it. That's where we break trust with our business partners, and you get into that fight between product and engineering. But if you can take time and express what you think the problems are and why you think it's a problem for a business. I spend a lot of my time doing this, right? I want to make changes to the way we deploy software, or the way we test software, or the way we build software. You have to back up and explain, what's the value of this? Where's my payback to the business on this? And build that trust over time, such that you can, make those investments.
Why is it so hard to get right? If I think back at some shared examples that we have, and also some that I have in my own history, I've seen examples where, it's been the business running at endless feature after endless feature without making the investment in actually in scalability, longevity, extensibility, productivity for engineers, right? And it creates a mountain of technical debt that just can't be overcome. And thus you're chasing the value because you're going so slow at delivering value in the first place. I've also seen the very opposite. I've seen engineering teams that get so wrapped up and enamored on, I call it the Russian nesting doll of value, where they convince themselves that building this new thing is great, and then only at the end do they realize that really that doesn't get you any value. You have to then build the next thing, which is going to get you value. Get to the end of that only to realize that no, that's just a precursor to building the next thing, which will get you the value, et cetera. And you never actually get any value. And it's an endless re-architecture cycle that never actually sees light of day or never sees value from the business standpoint. And so, you've been very successful, when I'd say pragmatic, at finding the right balance, both at Root, when I think about some of the things we worked on there, both in terms of architecture, and you led the team that was really focused on engineering productivity and making architectural improvements to that end. I also think about the work that we did together at Huckleberry, and in that scenario, we re-architected the platform from the ground up, and the team was a really good team when we joined. And so I don't want to make this sound negative, but it's been a year prior struggling to deliver value, partly because the COVID, partly because the business was in some turmoil. People were coming and going, partly because they kept having to sort of start and rethink about the approach they were taking. And, we went in there and we were able to build a new architecture that unlocked a ton of productivity. Went from, I think, a PR every 2 weeks per engineer to a PR at least one PR per day per engineer. That sort of pragmatic value. And we saw self-binds at Huckleberry where, it was less than 1%. And that old architecture was 40%. I think by the time that you and I had left the organization, if not maybe 50% by then. And so I'm just curious, how do you avoid that pitfall? Like, in some practical terms, how have you avoided it so you haven't fallen into either one of those camps of the endless refactor or the endless chasing tail of feature after feature?
Yeah, and I'll answer that in two parts. Going back to when I moved to lead the productivity team at Root, I was the engineering manager on telematics, and I was approached by Bob and yourself to come over and lead this. I think it was at the time called application architecture or application infrastructure, I think. And the name didn't make much sense to me. And no surprise, the team didn't make much sense to me, right? We had some of the most talented engineers at Root working on that team, Kyle Thompson and others. But they weren't really hitting above their weight, right? They weren't even really hitting at their weight. And it was that kind of endless refactoring nesting doll problem that you mentioned. And I think there was two things going on there that we quickly saw and we quickly put steps in to address. There wasn't a long-term roadmap vision of like, what should this team do? How should this team provide value? They found problems they thought were problems and worked on them because they were interesting, right? And they made great stuff, but it didn't have the impact because it wasn't traced back to what's the value this is going to provide. So before I did anything with the team, we started developing a roadmap of how was this team going to operate? What difference was this team going to make? And then they had some projects running and I let them kind of burn those down. I said, okay, now here's what we're working on, right? Here's how we're going to provide value. And we took off a few projects and delivered those rapidly, made some great improvements to our build system, really shrunk our Docker images down, really made some super impactful ways to how the software is built, and then eventually tackled, the architecture of the system that was causing us so much time spent on running tests and flaky tests and engineers having to have like way too much in their head to do any one change. So we kind of got out of that mindset. And the other thing that was going on there is the board at the time was literally like a row for every engineer. No one was working together. It was like, I'm chasing this problem, he's chasing that problem, and everybody's just kind of like chasing the problem that they're interested in. And I firmly believe that, two heads is better than one, many heads is better than two. And so of any project of any size, my rule was like, at least two engineers are going to look at this, right? Divide and conquer where it makes sense, pair where it's difficult, and we really need to be careful, and deliver value that way. I don't believe in, forcing people to pair all the time. But I also don't believe in everybody just goes off and does their own things and never talk to each other. I think the optimal path is somewhere in between, and you encourage engineers to pair, you offer the opportunities for it, but you don't force it. So I think that's an example on that kind of, nesting doll problem that we had, and how we dug our way out of that was going back to that business value. Moving on to Huckleberry, that was pretty interesting, right? I think what had gone on there was a lack of communication between product and engineering, and often or not, this is on the fault of engineering, of not communicating when we're doing suboptimal things, right? When we're taking shortcuts, when we don't have enough testing, when we don't have a good build system, when things aren't repeatable. If we're not communicating that back to our business partner as we're doing it, they don't understand, right? Things are going really fast in the beginning because there is no debt, right? There is no problems, but we make these small decisions along the way that add up to all this debt, but yet we haven't been communicating that to them, right? So, get this feature out. I think the reason that becomes, a battle and a tug of war is because as those decisions were made early on, no one was communicating how that debt was accumulating. They may not even realize it, depending on their level of experience, of like, yeah, this stuff we're building is going to be hard to maintain and hard to build on in the future. So Huckleberry was interesting because I don't normally, endorse this as a way, but we kind of started over, right? We looked at the existing code base and we said, there's not a clear way out of this, and there's not enough code here that it's that challenging to reproduce, but we need to reproduce it in a well-architected manner where things are well separated. I think if you remember the JavaScript code we replaced was just, there was no way to identify what a class did. It just did whatever the engineer put in it. Nothing had a meaning or a reason behind it. Whereas the architecture we put in place to replace it with Ruby on Rails, me being who I am, was very segmented and very encapsulated, where everything had one purpose, right? Transform this to that, save this in the database, send this message, right? And that makes it very easy to fix and change and adapt. If you need to introduce something new into that flow, it becomes, write your new thing and plug it into the flow, right? And it really was that simple. And also, we wrote a lot of tests, a lot of good tests, not only unit tests, but integration tests that stressed the entire thing and made sure that the entire endpoint worked, or the end-to-end thing worked, so that when we made changes, we were confident that A, we didn't break anything that was existing, and B, we wrote new tests, our new thing works.
Yep. And the word that comes to mind in both those examples for me is intentionality, right? If you in both of the, I don't want it to sound like we're being critical of either Root or Huckleberry, and I can name 3 other companies and 3 other concrete, tangible examples, but both are actually true at both examples we just sort of talked through. At Root, like you said, there was the best engineers at Root, ones that I still view as some of the best engineers I've worked with in my career, and that was a career that spent 7 years at Amazon. Had focused on trying to re-architect, but the intentionality behind it was, wouldn't it be great if we could have this robust billing system, right? But robust doesn't actually describe what the billing system actually needs to achieve. What does it need to create in terms of engineering productivity, business productivity, the customer experience? It really just talks about this like very fuzzy, very amorphous end state where it's sunshine and rainbows. And you had the best engineers struggling to actually deliver value, to the point where even those billing changes sort of became orphaned, and we rescoped the whole team. And you did a heck of a job helping create the very, I'd say, both intentional mindset of what is the outcomes we want to achieve, how we know we're achieving them, what do we want to then start with, how do we want to prove to ourselves we're actually making progress to this goal, on both engineering productivity, system design, security, system design, encapsulation around some of the key systems, and not going service-oriented architecture to the extreme, or microservice, but certainly it was a monolith, creating this the true modular monolith and moving in that direction. And then Huckleberry, that intentionality, I would say, and there was intentionality of purpose. To your point, like the previous architecture was a 1.0. They were trying to find product market fit. They had built with the first partner they had a lot of the concepts in the code, aside from the code cleanliness, if you will, was really key to some of these concepts that only translated to one carrier. Well, then they started adding carriers and the concepts weren't translating. But instead of sort of pausing and saying, okay, let's refactor this, let's start adding some of these things in, they just sort of kept piling on. And I think if I remember right, at least I think the phrase at one point I used was like, it's like a poop sandwich. Like you have one layer on top of the other, and you keep putting more on, trying to solve the previous one. And you're better off just saying, unwind the whole thing, start fresh, and go again, and avoid all the complexity that's now being created, trying to deal with previous complexity and previous workarounds and such. And that's not unique to any company, but in that case, intentionality was around, we now have market fit. We need to prove that we can support and have an architecture that can support a variable number of platforms that meet some basic criteria of how a policy needs to be bound. And we want to create a platform that really empowers engineering productivity, both in reducing cognitive complexity of learning how the system works. Because I love the pattern you'd put together there. It's still one I'm sure you look back on, it's like every engineer looks back and goes, I do it differently now. But I love that sort of command, sort of operator command pattern structure, which has almost had a functional language-like component to it. Real tight encapsulation, because it allowed for true end-to-end automated testing, both at component level and across the whole system, without taking on all the craziness of having to build this, what's the word I'm looking for? Context, if you will, having to build context or pull context from the database. You could build it modularly and test all at once in a really short amount of time. And that really served us well because we proved and we were able to achieve both ends of that. We were able to achieve both the ability to deliver a self-binding experience for the consumer across numerous carriers and be able to surface those prices for those carriers and actually make the selections. But we also were able to go and create a crazy amount of engineering productivity to where we had a team of less than 10 engineers that were cranking out features, which was toward the tail end when you were there, but cranking out features like crazy. And I think that intentionality that you had set up there served us well there as well.
Yeah, I enjoy that architecture. I mean, looking back, obviously, there's things that were odd about it, but it was pretty good. I'm certainly not the first one to use like a command chain of responsibility kind of pattern, which is just basically what it was. But I do like the way it was designed and stitched together. I'm proud of that work. But I think one of the key things between the previous architecture and the re-architecture is going back to, you were talking about your three principles, and one of them was Yagni. You're not going to need it. I think they fell into a little bit of a trap there where you build one for one carrier thinking, well, I don't need multiple carriers, but you do, right? That was a key driver behind the business, was to be able to price people on multiple insurance and see which ones that their business is actually eligible for. And I think you smartly, and I probably complained about it a little bit, was like, no, we need to build three of these at once, right? Two or three, I don't remember the number, because the system needs to support in number of carriers in the back end. And I think if you say we're going to support more than one, but you only build one, it's probably not going to support more than one very well.
Yeah, we actually wanted to launch with three. I think the team was feeling a little ragged, and you included, about getting those three out the door. And I wanted to get it out and get it prove it as soon as possible. We started with two, if you remember, but we did that very intentionally. We wanted to prove that, okay, they could only do one before. We can do two, with the third in the hopper, and then the fourth following shortly thereafter. And that's what we did. We went live with two immediately. We ran into some issues, of course, but if you remember that was probably one of the smoothest go lives of a re-architecture I've ever been a part of. And again, that includes 7.5 years at Amazon, where we launched some pretty big systems and pretty big user bases. That one was, man, like 4 hours of a couple key little fixes at the very beginning, and minor bugs from there for the next week that we fixed, and then off to the races for the most part, and banging out those other carriers.
Yeah, that launch went great. That architecture was easy to test, and I think that had a large part of why that went so smooth.
So let's pivot. I'm curious, have you ever been in a situation where the paradox was real? Like, we talked about like how the paradox can in some ways be self-created, but there does seem to be a few instances where that paradox, outside of being self-created, could have either already existed, or you get caught into it from nothing, not because of anything of your own doing. The situation creates the paradox. Have you ever been in one? And if so, like, were you able to get yourself out of it?
I can think of times where I've joined an org where the paradox does seem to exist, right? Everybody's fighting, between product engineering. I want to get this feature out. Oh, I need to do a re-architecture. Things are hard to do. And I think that's where it really comes in, when tech debt has accumulated, right? To the point where small changes are hard. It's very hard to explain to the business, like, oh, I know you want to change this thing that's really, really small and you think is really, really easy. And probably importantly, a number of months ago or a number of years ago was really easy to do. But now the engineering team's telling you, like, oh, that's really hard. It's going to take a really long time. And that's really easy to see how that would stress that trust. Well, a year ago, I could get this in a day, and now you're telling me it's 2 weeks. And that's hard. Something I think I've done, twice in my career. A previous startup I came into Halo, the iOS app I was working on at the time, was the architecture was very fragile and extremely hard to make changes, extremely hard to test, had some weird scaling edge cases that one of the hardest bugs I've ever solved in my career, honestly, was that. And I came in and started working on it, and I was very clear that, like, hey, we need to start refactoring this if we want to go faster. Here's what I'm dealing with. Here's what I want to do. The difference was the way I approached it, which I think made sense. I think replacing the code at Huckleberry, I think, makes sense. Replacing this application, I didn't think makes sense. But every engineer that had looked at that before me said, "Oh, we just need to rewrite this from the ground up." Right? It didn't need a full rewrite. Right? It had some deficiencies under the covers, but the screens, the user flows, all that stuff was pretty good. We can, to use a metaphor I've heard before, we can replace the engine of the car while we're driving down the road if we're careful about it. And so that's what I set out doing. I said, every time I touch something, if it's more than a light touch, we're going to start refactoring this, and we're going to, it has a lot of thread safety issues and other, scaling and performance issues. We're going to start making progress on that as we get features out, right? And the business saw the value of that, because one of the metrics they was tracking was the crash rate through Crashlytics, and it wasn't terrible, but by no means was it good. I think it was somewhere around 96% crash-free users, which doesn't sound that bad, but is actually pretty abysmal, right? As we made changes, I looked at those crashes and I looked where the most frequently crashes were happening and refactored that part of the code first, and we quickly brought that up to like 99.6% crash-free users. Most users are not experiencing a crash ever, and the ones that do, it's very, very infrequent. So you build up trust with the org, taking a more measured, and I think, to use your word, an intentional approach about those things. And I think the other time is where I'm at now, right? They've moved quickly for a lot of years. We still, even to this day, we, have been there for about 1.5 years, like you said. We've got a lot of tech debt, and I'm trying to teach the engineering leaders there, the tech leads, to communicate when they're doing things suboptimally, even if we still do it that way, right? You want to make a fee change in a particular country on a particular scenario that really isn't supported by the code paths that are there today. We can say, okay, let's make that happen as fast as possible, because there's some critical issue with that company, but let's report that back to the business and say, hey, we're taking some shortcuts here. We really want to do it this way. If we want to get this out to market, tomorrow, we can do it like this. We would like to then come back later and refactor that, right? So that we don't leave this kind of, ticking time bomb hidden in the code. So it's intentional. It's an intention about purpose, but it's also intention about communication, which I think is really critical.
You made two great points that I just want to touch on briefly. The first is you talked about the fact that engineers sometimes want to fall into the, hey, we got to rebuild this all. And I think it's important. And I think this is really key. I mean, at Huckleberry, we made that decision. Like you said, the architecture, it got to the point where it's like, what can I actually build on? And we realized that as we kept going, picking and poking and sort of drilling through, I don't want to call it rot, but it was one layer of inefficiency after another, to the point where it's like, there's no foundation here to start with. We're better off rebuilding. There's a lot of times engineers look at a hard problem like that and go, it's just easier if I rebuild it. But ultimately, it's no different. And we both share a love and passion for home remodeling, home building. We both do that some of our own time. You don't take a house, whether your house you're living in or if you're investing in property, get the property, immediately say, man, this isn't exactly the way I want it. Let's just blow it up and then we'll rebuild it from scratch again, right? Like, there are times you need to do that if truly the structure of the building is at a point where you can't find good wood to build from, and you look and every board you pull, everything is just termite infested or rotted or molded, And you get to the point of, I have to salvage here. I got to rebuild it all. But very rarely is that truly the case. Like usually you get to a point where you say, okay, there's something I'm going to build from. Here's what I need to fix. And that fix may take time. It may take a periodic rebuild, or if you're remodeling your home, you may have to start one room at a time and do it slowly, right? Engineering is no different. Like making those investments, because that's what I've seen personally of the paradox has been when someone's been in a death cycle. The death cycle being that they're so far behind on trying to create business value that now the business is behind. They're chasing dollars, they're chasing opportunity, and they can never actually make the investment to fix anything to begin with. So they keep trying to build and layer on top, which is just a self-fulfilling prophecy. And you almost have to start somewhere and say, okay, I may not be able to do a room at a time. I'm going to simply, on this thing that I'm building, I'm going to try to clean it up as best I can so that little piece of the world is now solved. Whether it's technical debt on testing, technical debt on architecture, that I can't fix everything at once. I'm going to start here and fix this and then work from there. Part of that's being intentional about how you want ultimately all to look like, but you're making a small investment that you're hoping will, much like paying off a credit card, you can eventually pay off one balance, which snowballs in the next, et cetera. To that end, too, you talked at the end. I hope I don't forget what my point here was. The communication around when you are making a choice like that, the cost of the choice, and again, much like a home building exercise, right? I have a contractor coming into my house, and they're making a decision, right? I, as the homeowner, right, will call myself the product manager or the project manager on that, may say, hey, I have my windows leaking. I want you to fix it right now, right? A fix may be put silicone around the window. That may be a great short-term fix. It's actually not the right long-term fix. The window may already have some rot on it. The contractor may say, look, the right answer here is to replace your windows. It's a $50,000, $100,000 investment. It's not to be taken lightly, but ultimately these windows need to go. They're all approaching end of life. I say, look, I'm going to make the decision for now, put the silicone around the window, try to get the leak to stop. I'll deal with this in 3 months, 6 months, 9 months, a year from now, whatever. But if that contractor doesn't tell me that, and I say, can you just put some silicone around? And the contractor goes, yeah, great, silicone done, and walks away. Well, I, as the homeowner, is going to be pissed when I eventually go to realize that the window 6 months from now, the silicon's failed again, and it's right back to where you started. And I think engineers need to also internalize that sometimes it's not about product leadership or executive leadership not wanting to make those investments. Sometimes they don't know the investment needs to be made or why that investment needs to be made and what the current situation on the ground is. And our job as both engineers and engineering leaders is to communicate that in a way that is digestible, much like the contractor is saying, look, let me explain to you about the windows and what's happening. I can do this short fix or this quick fix. Here's why this quick fix isn't going to hold for long, but it'll get you through for now. Here's the right long-term fix and why, right? Any questions? Then, whether it's, again, a product leader or executive leader may come back with a, well, could we do X or could we do Y or could we stage it a certain way, right? That's not them trying to cheap out on making that investment. It's them trying to understand and appreciate the investment you are asking for so they can hopefully get to a yes on it. And it's just a matter of how to orchestrate it. And I think a lot of engineers, and I think, Tim, it's super astute that you called this out, a lot of engineers forget part of their job is to educate technical or business leaders or product leaders on those trade-offs that they're seeing in the moment. Even if is a trade-off to be made, educate them on the cost and the benefit of the trade-off. So when that joint decision eventually gets made, there's a full appreciation of all the sides that cost, not simply the engineer who can solve it and get it out the door in a day, right? But nobody knows what they're creating is a pile for somebody else to clean up a week, a month, a year from now.
Yeah, I think too often engineers look at a hard technical problem and they don't think they can explain it to product or the business. They won't understand, right? But part is growing as an engineering leader is learning to be able to describe those technical struggles and issues that we have in a way that non-technical stakeholders can understand, right? Tying it back to the value is where I always try to go, right? if we do this, it will be faster to develop this on this feature later. If we do this, this feature will be more stable, less users will have issues with it, right? What is the value of the thing that we're doing? At the same time, you mentioned, doing the silicone and cheaping out, and it may not be, product or the business cheaping out on doing it the quick and dirty way. And you're absolutely right. The business needs to make it clear what the priorities are and what is and is not important, right? As that we know today. So engineers understand why those trade-offs are being made, right? An engineer wants to, to extend the metaphor, do some silicone on this or replace the entire window, and really wants to replace the entire window, right? And the business is like, well, you want to replace an entire window of this thing that's not critical to my business when I need to get out these, 5 other things that are, gonna save us this year, right? I'm gonna ask you to do the silicone. But if you don't understand why that choice is being made, it's very easy to interpret it as, oh, they never want to do the right thing. They always just want to do the cheap and dirty thing, right? It's usually not the case.
Yep. No, that's a great point. Like in leaders, whether it's on the product side or even the executive level, leaders have the responsibility of communicating those objectives, those challenges, right? There's a lot of leaders that struggle with trying to be transparent about, hey, look, the business, the current economic environment is challenging. And right, we here's the things we're up against. Here's some of the targets we're running at and why we're running at them. Right. Everyone may be, I don't say frustrated, but everyone may be disappointed or wish you could do more. Right. But ultimately, if everyone's mission aligned to what you're working on, the team will understand that. And again, then the situation hopefully is that the leader will also understand what those trade-offs are, and like, hey, look, I'm making a short-term decision. I'm living on the credit card, so to speak, because I'm hoping I can get to a point where I can start paying that back. And so you're right. It's actually both sides. It has to be communicative and be explaining, because ultimately, right, it does create a deficit of knowledge on both sides if engineering isn't explaining those trade-offs and the cost of them up to product leaders, software engineering leaders, at a higher level, business leaders, and vice versa. Business leaders are creating a deficit, or product leaders are creating a deficit with the engineering teams if they're not being communicative about the business challenges or the business opportunities in front of them and what they're wrestling with and why they're prioritizing something over something else.
Absolutely.
Man, we covered a ton of ground quickly, Tim. I have a couple other questions I think I'd want to ask, but I always like to offer an opportunity for the guests on the show to ask me questions. Is there any questions you'd be curious about me answer, or me being able to answer for you?
Yeah, I do have a question. We covered it a little bit, but because I think it's kind of the exception that proves the rule. When you took on the role of CTO at Huckleberry and then brought me in, you had ultimately decided on a complete re-architecture and replacement of the existing system. I think my question's twofold, right? A, how did you come to that decision? And then B, how did you convince, especially as a new leader in an org, that the rest of the leadership that decision was the right one?
That's a great question. So for me, when I got to Huckleberry and I had joined, I accepted the role back in January of 2021. I was transitioning out of my role at Root through February into, I think it was into early March, and then joined Huckleberry. I'd already been sort of on my own time digging in to the architecture, digging into the challenges and the roadmap the business had. And I saw that, supporting more carriers was a thing. Started getting data on the current platform and how it was operating, which was still in that super early, like found market fit, but a lot of person behind the curtain type activity going on with the solution as a whole. And as I started digging into the code, I loathe just somebody who comes in and says we're re-architecting. And matter of fact, the last 2 times I've been a CTO, I've actually wound up going down that path. And especially the last time actually at Lower, I tried to avoid it at all costs. Like I really didn't want to do it. And I got to the point where the team had put enough data in front of me where I realized that I've also made this mistake a couple of times where I've held off pulling the trigger on that and then regretted not pulling it sooner. And actually, at my last experience lower, I regretted not pulling it sooner. I tried my best to make it work, and just realized every time I thought we had gotten to sort of solid ground and being able to build back up, found that it was actually quicksand. And at Huckleberry, it was just really obvious that they had grown so fast on that previous architecture, and with a team that was really hyper focused on finding that market fit, where they didn't have the right abstractions. And I could see in the code base that trying to even clean it up to get it to the point it felt like a lost cause. And the abstractions were across the board missing, that it got to the point where I realized, with the size of the actual code base and what it was doing, right, there's a lot of things that it thought it was doing, but when you actually got to the gist of it, it wasn't a whole lot that was actually happening under the covers. It became super obvious to me that trying to simply make this work was actually going to take longer than just starting fresh, but doing it with a very tight mindset to what do we want to accomplish? Like, ultimately, it was about being able to prove to ourselves we had the right abstractions to support multiple carriers. We wanted to support a consumer coming into the flow as little amount of data and questions they had to either provide or questions they had to answer, be able to qualify to see bindable quotes. And then even in cases where those quotes weren't bindable for whatever reason, all the information was there ready to go for a sales representative to go tackle that. And ultimately, in terms of the productivity, we wanted engineers to be able to build, but I very much value simple solutions solving complicated problems. And to me, like that previous architecture with it was like Node with a bunch of promises everywhere, which were just hard to follow, let alone understand. Like the cognitive complexity it was solving simple problems with what felt like very complex solutions. And the beauty of what you helped and really owned architecting was, while there was rigor in it, it was pretty simple in some respects at the core. There were some little nuggets of complexity here or there, but there was cognitive simplicity in the sake. Once you learned the pattern, you had it everywhere. It was super easy to understand. And then it just became a matter, honestly, the challenge was all the carriers in commercial insurance. For anyone who's listening who's not familiar with it, the APIs are all dirty. I'm sorry, they are like just nasty to work with. Some of just really, really poorly documented, inconsistent. I won't even go there. It was really, that was the challenge. There was complexity and challenge in some of these problems. Some of it was just like how to build something that was durable, a durable sort of interface or facade against some of these third-party carrier APIs that weren't built for the prime time, but on our side, supporting it and giving an experience that was highly available, highly scalable, low latency. And to me, like that was the impetus for wanting to really making that decision. It was the exception of the house that it would have cost more money to try to fix it in place than bulldoze it and build it again. And we actually proved that when I think we started in earnest in March of 2021, rebuilding it was like mid-March, if I remember right. And we went live with the new architecture the second week of July, I believe, of 2021. So 4 months, give or take, we went and had a architecture that had 100% test coverage, that had 2 carriers fully supported, the 3rd carrier and 4th carrier in flight being built on the scenes. And honestly, those carriers would have been done if not for the complexity around the carrier side, the APIs, the crudginess of it. We would have had all 4 live probably by July. Was there a second part of that question, by the way? Did I miss a part of it?
Yeah, the second part of that question was how did you convince the organizational leadership that was in place that was the right decision, especially being a new leader?
Yeah, I thought there was a second piece. I couldn't remember what it was. So at the time, I met with the CEO and walked him through the why the current architecture was problematic. Some of it was self-evident. Now, he was a business leader who wasn't a technologist by trade, and so he could see the symptoms of the problems, but didn't understand why they were happening in the first place. Data wasn't consistent. There were times where we thought the data was telling us one thing and it wasn't. They couldn't, they had this one carrier that was integrated, but even that integration was brittle, wasn't very durable. The self-bind percentage was pretty low because of that, and they had to do a lot of manual work to get policies fully bound. And so when I walked him through that and showed him both the current challenges, why, and the developer productivity metrics, et cetera, and I showed both eventually then we brought it to the board in my first board meeting, and I presented the board with my plan. And for context, the board at that point had actually heard for the last year before I joined, they were going to redo the architecture, and it was going to be all these carriers. And right, well, none of that came to pass for all sorts of reasons. And so when I joined, I said, look, you may have heard this message. Here's what we're doing. Here's how I'm going to prove to you what we're doing. Here's what I'll show you what we're building. And when we're done, here's what it'll look like. And then I think that was in the Q1 board meeting. When I came to the Q2 board meeting, we had just launched the new site. We had data on self-binds and all this, and we were able to show engineering productivity and the self-bind data. So when I came back to the board, I said, and I told you, here's what we were doing. Here's the value we get from it. Here's how we measure it. I'm coming back, and I just literally showed those exact same slides. And I said, here's the value we got. Here's how we're measuring it. Here's the impact it's having. And it both selling it up front made it very tractable for our CEO to understand, as well as the board to understand. But then the sort of where you earn trust and you earn you earn respect is when you then go and do it, and then you come back and say, here's how I told you how I'd measure it, and what I was here either my thesis, or here I knew what we could do. Here's how we were going to prove it. Coming back now and showing that data, being transparent with it.
Yeah, absolutely.
So Tim, I want to just pause here. So Tim has a blog that he writes, and I want to make sure I pronounce it right. Is it DevNops or DevNops?
I call it DevNops.
Dev. So it's DEV, D as in dog, E as in Einstein, V as in Victor, hyphen, N as in Nancy, O as in ostrich, P as in pear, S as in Sam, .net, where you talk about engineering concepts. One of the concepts you've talked about more recently is ChatGPT. And I was actually going to make a joke earlier in our conversation when you talk about the sort of the trap engineers fall into. There's been a lot of engineers that have been looking at ChatGPT as like either it's the thing that's going to end the world or end our world as we know it as engineers, or they've looked at it as, oh my God, like it's going to do everything for us and it's going to take all the dirty work away and we'll never have to do any of that anymore. So tell me about your view on ChatGPT.
Yeah, sure. I call my ChatGPT post my obligatory ChatGPT post because everybody's writing about it. And I was really late to the party. But you're right. I saw a lot of, gloom and doom. This is going to replace, everybody's jobs, right? Nobody's going to have a job. Lawyers, doctors, computer, software engineers, all these things are going to be replaced. I'm old enough to remember I think what they called like 4GL languages.
Oh yeah,
that were of a I don't know, flair there for a while. You're just gonna drag things around on the screen. You're just gonna kind of define your table, and there's gonna be no software to write. It's all gonna be drag and drop, plug and play. And that never really went anywhere, right? Coding is hard, and my blog post kind of focuses on, even if coding is hard, what's harder is reading code. There's a lot of data that says, reading code is way harder than writing it. And we spend about 10 times more reading code than we do writing it, right? So the question I raise is, if ChatGPT is writing all this code, who's going to read it, right? Who's going to make sure that it performs as it expected? It's got to be a software engineer, because who's going to understand the code, right?
Well, not just that. I think the article, I think you sort of made a point that I hadn't yet heard made. I thought was really interesting and illuminating. Is if engineers sometimes struggle to get code right, and ChatGPT struggles, for everything it does well, or maybe spits out has the right answer, plenty of things spits out have the wrong answer. What is ChatGPT going to learn from ultimately? And if errors are making their way in, won't those errors just compound over time when engineers learn from ChatGPT, potentially learn the incorrect stuff, don't understand it, and then they teach ChatGPT how to then code better?
Yeah, I don't know what happens when ChatGPT starts consuming its own code, but it doesn't seem like anything good could come of that. There's no additional learning to be made there, right? I think Stack Overflow and others are looking into how do they license their content to these these large language models companies, because Stack Overflow and all of us in the community have spent decades building up this knowledge base. And it seems weird that ChatGPT is going to come along, consume it all, and then supposedly put us out of business. I don't see that part of it happening. But if it kills those kind of communities, what is it going to train on next, right? So there's some interesting things to figure out around ChatGPT. I think in the blog post where I'm far more concerned about its impact on misinformation than any kind of future job prospects.
Yeah, well, I mean, if you play around with ChatGPT, I was actually using it the other day. I'm constantly I own my own business, obviously Leverage Loop, where I engage both fractionally for fractional engagements as well as advisory and coaching of executives, both technical and non-technical executives. But I still love building, and so I'm working currently on a potential product idea, and I was using ChatGPT just to sometimes you get that I'm going to try to come up with a name for the new company if I'm going to start one, and so I told ChatGPT, here's my criteria for the company. Here are the areas. Feel free to choose synonyms for these words. Don't end it with EX or IX, because every consulting company under the sun has a name that's like ends with X or Trex or something like that. And then I said, I want it to be 3 syllables or less, 8 letters or less. And I want you to check to make sure the domains for these names aren't registered and don't resolve. And ChatGPT came back with a list of 10, I thought, great names that said, I checked, domains aren't registered, .coms aren't registered, and they don't resolve. I go grab the first one, like, this is a great name, I love it. Go check it in the who is, and sure enough, it's registered, hard registered. Not even like it was tough to find that it was registered or it didn't resolve but registered. No, it pulled the website right up, and clearly the domain was registered. So I asked ChatGPT and say, like, why did you give me results? I told you to check it. Well, then it says, oh, I'm sorry, that's my mistake. I didn't do that. Let me do it again. Spits out another list. Start picking names there. I'm like, these names are not as interesting because now they're getting a little more cryptic, but that one looks interesting. Doesn't resolve. So now I asked ChatGPT, hey, why did you give me this specific name? It shows this registered domain. ChatGPT comes back, I'm sorry, I made a mistake. Let me do a deep search. Well, then it takes its time. Like, I can see it's taking time to generate the thing. Comes back with 10 names that I think are all garbage. Yet they actually didn't resolve. And so you wonder, how is the model actually learning in the first place? But why isn't not with very clear instruction? Why isn't doing it the first time? I'm sure there may be something they're actually experimenting and learning with, an OpenAI side, but it just goes to show it knew it was making a mistake, and yet it still did it anyway. Which is no better than some professionals that bullshit and say, I did that, and then you're like, but I just checked your work. You didn't do it. I just proved it. Oh yeah, you're right. My bad. Let me do it again. So I'm not sure we've actually moved the ball forward at all in that regard. The one thing I do think that ChatGPT, I don't think it's going to be the Terminator anytime soon. And it's not going to be Skynet. But the one thing I do think it could actually add value to, especially in the engineering paradigm, is ultimately when you're trying to add test coverage to your code, right? I could see ChatGPT actually adding a lot of value, helping identify how to make your test coverage better, or how to identify where your test coverage is lacking and suggest actual test infrastructure or test fixtures to actually cover that. I think that would be a great use case for ChatGPT, where it could be making those type of suggestions, writing code that's boilerplate, writing code that's pretty easy to templatize in some respects, but doing it on behalf of the engineer so that you're not having to constantly go and find and grind on that stuff. I just, I think your point's well taken, Tim. Like, I loved your article because of it. Like, ultimately, like, part of the whole ability to gain understanding and knowledge is about being able to learn, ingest, understand, build on top of. While I think AI is still, it's way ahead of where it was, and it's, I think, opening a whole new set of opportunities for productivity. I still think AI is really good at faking it. And this is true even on language learning or the learning model side for translation and for language. When you talked about statistical machine translation versus neural, even when I was in the translation space back at Amazon in 2017, 2018, neural machine translation was fluent. You couldn't tell the difference between what on the surface, you couldn't tell the difference between what a human translator did and machine translation when it came to neural machine translation. It was that smooth, where statistical was very, very robotic in some respect. You could, make clear mistakes when you tried to build these words and build these phrases up from it, because you had a, sentence grammar alignment, all that stuff was harder. Neural, the sentences were fluent. The problem is you would occasionally get sentences that made no sense. Like, they were fluent, the king's robe was hot. Okay, well, has nothing. That's not translated well, because why would that make any sense? Or, the king thought his robe tastes good. Okay, it's a fluid sentence. It just don't make any sense in context. And I see in some respects ChatGPT doing things like that, where it can actually put information together in a very humanistic way that feels very fluid. But there does things at times where you're just like, that's like confidently wrong. Like, you're projecting confidence in your answer, and it sounds really great, but I know it's actually factually wrong.
Yeah, no, I couldn't agree more. That's why, and I probably could have explained it better in an article. That's why I ended the sentence with I'm more concerned about the impact on misinformation, right? We have a lot of misinformation out on the internet, but ChatGPT will confidently produce, misinformation if asked, and it will do it in a really easy, fluid, extremely human readable way. And yeah, I'm concerned, about people using it to, write articles or do anything where no one's, if people aren't fact checking what comes out of it. Same thing with, checking the code that comes out of it, right? It'll confidently give you code that says, like, yeah, this does what you asked me to do, but it turns out that it doesn't, right?
100%. Well, we could keep talking all night, and this was super interesting. Tim, thank you so much for taking the time to join us today, talking about the balance between I'll call it pragmatically approaching feature development while being intentional about building long term and avoiding that paradox that we led with here, the engineering paradox.
Yeah, thanks for having me. It's an enlightening conversation and helped me understand my thoughts along it a little better.
Cool. Well, we'll be coming back with more content in the near future. Also, more than likely, the next couple of series will be on more engineering topics. So stay tuned. Thanks, everyone.